In 4F, we're talking about sequences and functions. A sequence is a list of numbers that usually follows a pattern. Each number is called a term of the sequence. Example 1, describe the pattern and find the next two terms. So you have to play around sometimes with it a little bit, but 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. And 15 plus 4 is 19. So the pattern is add 4. The next two terms then would be 19 plus 4 is going to give me 23. And then 23 plus 4 is going to give me 27. Example B. This time, you might think subtract a pretty big number, but if you look at the next one, you can see you can't subtract that same big number. So this is not going to be subtraction. 81, though, divided by 3 gives me 27, and 27 divided by 3 gives me 9. 9 divided by 3 is 3, and 3 divided by 3 is 1. So it appears then that the pattern is to divide by 3. So when we go to do our next two terms, we're going to have 1 divided by 3. So at this point, we need to remember that dividing by 3 is the same as multiply by the reciprocal, which is 1/3. So 1 divided by 3, or 1 times 1/3, is 1/3. And then 1/3 times 1/3 is going to be 1/9. So our next two terms will be 1/3 and 1/9. In an arithmetic sequence, the difference between consecutive terms is constant. So it does not change. In these sequences, the pattern is adding either a positive number or a negative number. The positive or negative number is called the common difference. And it's used, the variable used to denote it is D. So this is an arithmetic sequence. We're going to learn about some other sequences at other times, but in arithmetic, the pattern is adding, and you have a common difference. All right, so now what we want to do is example 2, is we need to look and tell whether each sequence is arithmetic. So in order to do that, we need to say, is there some common number that I'm going to add to everything? Well, this looks quite frightening, right? There's lots of fractions there, and this is a fraction that's not. But what you need to do when you're working with fractions is to get a common denominator to see if there's going to be a common difference. So I've got here 7/3. 2 would be how many thirds? 6/3, right? Then I've got 5/3, 4/3, and then 1 written in thirds would be, that's right, 3/3. So now if you look at it, we have 7/3, 6/3, 5/3, 4/3, 3/3. So we do on this one have a common difference of minus 1/3. So in other words, what I'm going to add each time is going to be negative 1/3. So 7/3 and plus a negative 1/3 is 6/3. So that's going to be my common difference. So D is going to be equal to negative 1/3. Example B, I'm adding, that's a little easier, that's plus 3, but this one is plus 5 and then plus 7. It's a nice little pattern going here, but it is not a common difference, so I'm adding different things each time. So this one is not arithmetic. So I should have said over here that this one is arithmetic. And the difference is negative 1/3. Now there's going to be some terminology as we get into some formulas that we're going to look at in just a minute. And this is going to help us a little bit here. Function notation can be used to relate the term number, which is going to be n, so the number of the term is n, to the value of the term, which is a of n.